Today we'll be doing a full session on no-till pasture rejuvenation. And I'm very excited to be sharing this work. It's a topic that takes up a lot of my spare time. I think a lot about it and always trying to solve these puzzles. So for our presentation here today, I'm going to give a brief introduction to myself and the project that led to the work that I'll be presenting today. And then I've divided my talk today into 4 different parts. We'll start with looking at the key components to reestablishing a field, then move into some specific considerations for no-till field rejuvenation. We'll jump into one of my favorite topics, soil carbon and tillage or no tillage. And then finally, we'll wrap up our session today with some key messages and a summary to take home. I think it's important to note that I am building off of previous presentations that we've done in this webinar. So there's some of these topics that I might not go in depth with, or might cover really quickly, kind of based on the assumption that we've all been kind of on this journey together. Hopefully that means that everybody can come along and everything makes sense and doesn't feel too rushed through. After each part, we will have a time to take a quick break and answer any questions and jump into a bit more discussion on these topics. So I might be a familiar face through all these webinars, but perhaps haven't had the opportunity to introduce myself fully and my background. So I am born and raised through the Cariboo, so I am from the central northern interior and happy to be making my career and life in this region. It's very rewarding. I started my education with a Bachelor of Journalism from Carleton University, and then came flooding back to Northern BC and did my Master of Science with the University of Northern BC. And I have recently been able to complete my credentials as a professional agrologist. Most of my work is, and my areas of practice right now are looking at crop development, production and management, as well as education and extension, and then research, technology development, transfer and application. So fairly diverse. A lot of the work that I've been working on right now and over the past 10 years that I've been working throughout the region is mostly focused on crop physiology and breeding. That was what my thesis was on. Very interested specifically in forage crop establishment, nutrient management, that soil, plant soil complex, all of those pieces. But really, at the end of the day, I would describe myself as an advocate. I'm very committed to applied research, and what really makes me enthusiastic and the love that I have for my work is actually the ability to work with producers and to help them solve questions that they have. So really, I'm hoping that all of the research programming that I'm able to deliver is very focused to be on farm and applied and relevant. So that's really what drives me and the work that I've been doing, which is how I got started in working with the BC Forage Council on these 2 programs. So since April of 2019, the Forage Council has been leading 2 different programs, one specifically in the central and northern interior of BC, so throughout the Cariboo and up into Prince George area. And the second was focused in the Kootenay and Boundary region. So altogether, we had 12 farm partners and 14 research plots. And for the past 3 years, they've all been very generous with their time and their knowledge as we work together to trial out different practices around the theme of no-till pasture rejuvenation. So these practices were demonstration research, so they were not really rigorous scientific replicated research programs. We worked with each individual farmer who outlined the goal of what they wanted to do, what they wanted to try, and then we walked through designing a demonstration research project so that they could compare the different components of those fields. So there were a lot of similarities. A couple of the plots did work on the same concepts, but very different soil types, very different climate, made it a very unique program in general to get started. So we've learned a lot, and it's through all of those learnings that I'm going to be presenting here today. So again, not necessarily going to be jumping will not be sharing any of the actual results. Those will be coming later, but really kind of diving into the key principles and concepts that we have learned along the way. And you'll see this slide again, to till or not to till, and why should we care? This is something that I see all the time, a conversation that's always happening. When we're talking about tillage, what we're really talking about is soil health. So we're wanting to do the best that we can to keep the soil where it belongs, that topsoil in the fields and ready to grow some plants for us. And when we're talking about tillage, we're talking about the disruption of soil structure, the potential for soil erosion, and as I mentioned, soil carbon is kind of the big hot topic these days, is really thinking about what we're doing to manage that soil carbon. And when we're looking at no tillage as well, the idea is that you're going to have less equipment passes over a field, and this could save some money, and perhaps very importantly for our future in climate change, it could also reduce our greenhouse gas emissions. So in a nutshell, that's why we're here tonight, and that's why we asked the question, to till or not to till. So part one, some of the key components, not all of them, but some of the key components to reestablishing a field. And now for this first section of the presentation, I do want to say that I would argue that these concepts work for any type of rejuvenation, whether you're thinking about tillage, no tillage, but specifically not just pasture. So all of the fields that we worked on for the research plots are pasture. All of the examples that I will be giving tonight are specifically about pasture, but I feel that the same principles can be applied to a more tame or managed field as well. So the four concepts we're going to be diving into are looking at the competition. So what is the existing vegetation that you have out in that field? Looking at what are the methods to get the best seed to soil contact, a really key component to establishment. And then the other two components are looking at field moisture, which may or may not be in our control, and nutrient availability. So we'll take the time to go through each of these concepts, a little bit of what we've thought about over the last 3 years, and then use some of the examples from the farm plots as well to hopefully demonstrate some of those principles. So competition, this is a very big key component to reestablishing a field. A lot of the time, even if existing vegetation, if you're describing it as tired or it's a really low productivity site, it's still a good chance that existing vegetation will outcompete your seedlings for sunlight, moisture, and nutrients. These grass systems, and especially if it's sod bound, they have deep roots. So if any of these things are limiting, they're going to get to those resources first. So one of the key things to think about is, how are you going to suppress that competition? So there's a couple of different ways. And as I said, I'm trying to be a little bit more general in these concepts, and then we'll dive more into no-till as we move along. But when you're thinking about suppressing the competition, one of the more conventional ways is mechanical. So thinking about tillage of various intensities and equipment used. Chemical application, so using a herbicide to kill back that existing competition, probably the most conventional way to do it with no-till. Overgrazing is one way, and I put in brackets maybe. I think it can be a challenging way to deal with competition, and it will have to fit in with your goals, and or close mowing, or a combination of all of the above. So regardless of which one of these you choose, you are going to have to think about how are you going to suppress that competition. So jumping right into some of our trials that we looked at, one of the big questions that we had really was actually that overgrazing. We've heard that these systems are being used in different regions. I believe particularly in New Zealand and Australia, where you hear that you're able to bring in the cattle, graze it really, really hard in the spring, let the regrowth come back in. A week later, graze it really hard again. And during that second grazing is when you would seed your pasture. And then 3 or 4 days later, you come back and hit it a third time. So this was definitely something we were hearing a lot about at the start of this program, and definitely had a lot of producers interested in trialing this out. This is particularly important for any producers who want to utilize no-till, but perhaps want to avoid the use of chemical applications. This could be because they're working towards an organic process, organic principles. It could be simply because they're trying to find a way to reduce their costs. And when we started this program, the stated goal for them was really that they wanted to see a shift in composition. They were okay if some of the existing vegetation came back, but they really did want to shift that composition and interseed with different species. So as I said, a couple of different farms did try this, and on the photo to the left of your screen, that does show a close-up of some germination that we got. This was a field that followed that grazing process with cattle in the Chilcotin region and came in. So these photos on the left were taken 2 weeks after seeding back in 2019. So you can see they got a pretty good graze lower down, and you did see those seedlings germinate. Unfortunately, in year one, they didn't establish. And in this trial specifically, there were several different annual cover crops that were trialed. So they had different strips on the field of the different annuals. And while we saw germination, none of them established. At the end of the day, they were outcompeted by that existing vegetation. On the other hand, we had another producer who tried to do the same concept of overgrazing, but they did it as strip grazing with first sheep followed by horses. This was in a different region. This was down in the Boundary area, and we didn't have any photos of the fields themselves, but you can see the sheep happily grazing at a different time of year in this photo. And as it happens, after the strip grazing, they did a broadcast and had the livestock kind of trample it in a little bit. And they broadcast quite a diverse mix. I think it was over 20 different varieties of different perennial species, some of which did establish. It was actually a bit more successful with the sheep and the horses in that grazing system to really manage and suppress that competition. So what we really learned, at least in the caribou example, or the caribou Chilcotin example, was that we couldn't push the cattle at the right time of year to overgraze as heavily as we needed to. They were just coming off calving. They really needed those nutrients, and they needed to be really healthy before they went out onto their crown range. And we just couldn't push them to get that competition back. So it wasn't necessarily that that technique wouldn't work. It just doesn't work with the other management practices that we're currently utilizing in the region. Whereas with the sheep and the horses, it seemed that you could push it a little bit back, a little bit further, and get some, you did get some germination and establishment there. At the end of the day, the producer did feel it wasn't quite as successful as they were hoping. So really important to kind of measure and assess what you're working with. But to take the example from the cattle and the Chilcotin a little bit further, after that first year, they're like, well, no, it just really didn't work. Let's try to use a little bit of chemicals to suppress it. So the plan was to spray out the field and try interseeding those cover crops again into that field. Unfortunately, the spring of 2020 was abnormally wet. We didn't have the conditions to get out there and to put out the herbicide as early as we wanted. And by the time that we did get out there, the vegetation was quite far along and we didn't get a full kill. However, that herbicide application was able to push back that existing vegetation enough, push back that competition, that they did get a much better establishment of that cover crop going in that second year, which you can see here. It wasn't enough growth for them to consider it worth going in and taking a harvest off that crop. So what they ended up doing was grazing it into the fall, into the winter, and then winter feeding their cattle on that field. And it was through that opportunity that after 2 seasons of trying to get a cover crop going and to help it with reestablishment, that in conjunction with the integrated livestock, they actually noticed a shift in the composition of the field by the 3rd year. They started seeing a lot more of the clover and some other of the other legumes come back. the grasses themselves started to come back more, and they shifted it enough and shifted the productivity enough that they were actually quite happy enough with the field that they no longer felt it was in need of a full rejuvenation. So could be a failure from what we wanted to look at when we first got started, but some really interesting lessons along the way as well. So really thinking about a long view and what the goal is for that competition, for that field. So some last final thoughts on the competition itself, some general principles if you're trying to sort out how does this apply to your operation. So more suppression of that competition is going to be required if you have a species in that existing stand that are particularly competitive or adapted to those conditions. So when we're thinking about that, we can think of any grass that tolerates frequent defoliation with good regrowth is going to be very competitive and is going to need a lot more work to push back and suppress. So you can think of Kentucky bluegrass and quackgrass as two species that are really going to be particularly competitive and particularly difficult to compete against, as well as any other species that might have vigorous growth in the spring. Further, if you're working under drier conditions, it's also going to be, you're going to need to make sure that you're really dealing with that competition. So existing plants with roots deep down are going to access any available water a lot faster than a seedling. So drier conditions are also a little bit more challenging to work with. And if your goal is to have a higher density of a species being reestablished, again, the more you're going to have to push back that existing vegetation. Less suppression is going to be needed if you have few competitive species that are in the existing stand, or if you're seeing some bare ground that is visible. That also might be a sign that maybe there's a little bit less of a suppression that you can push back. And when we're thinking about less competitive species, you can think of timothy, tall wheatgrass, meadow fescue, meadow brome grass, alfalfa. Those ones are definitely not going to be as competitive as some of the other species that you have. If you have more favorable moisture conditions, there might be more moisture to go around to support that seedling getting going. And then perhaps if your goal is to have a moderately density in your in the stand coming out, you might be able to get away with just a little bit less suppression. So the next concept that I said we'd address that's come up is how do you get that seed to soil contact? For strong germination, you really have to make sure that you're tucking in that seed right against the mineral soil. That's a really key part to give it the jump start that it needs. And this is, again, particularly important in dry conditions. So I know we have a substantial amount of dry land producers out there. So really trying to figure out the best technology and the best approaches to get that seed to soil contact. A firm seed bed really is ideal. You don't really want to be working with a loose or a fluffy soil. A lot of forage seeds, the seed size varies, but a lot of forage seed is quite small. So if it gets buried too deep, there just isn't enough stored energy in those seeds to push through the soil. If you are able to get a good packed soil, you're also going to be able to retain your moisture better than in the loose soil. And that firm seed bed is also going to help create a uniform seeding depth, again, which would support a more consistent germination. This photo comes from Quality Seeds, and it reminds me a lot of Grant Lastuca. If you notice that your seed is only germinating in the wheel tracks or the top of your hills or in that depression where you were standing, it's likely that you started with a too loose of a soil. You didn't have a firm enough bed to get going. So that's one way you can kind of tease apart what might some of the challenges in established might have been. So some of our trials did specifically look at different equipment to help determine whether or not different types of equipment were going to be better at getting that seed to soil contact. So here you can see an example where one of our operations, they did spray out. They put a herbicide treatment in the spring, and they compared the existing equipment that they owned, a double disc no-till seed drill, to an inverted T-tine seed drill. So this is The specific one that we rented was the Seedmatic Atchison, but the AgroPlow also puts out that inverted T boot structure. And as you can see with the photo that we've kind of enhanced here, is the idea with that boot is that you might be able to create a little bit more of that seed pocket, get a little bit better of that seed to soil contact and increase the germination that way. So we do have a quick little video here. So you can see the Atchison in action. So there it goes. So a few things, it was a rented piece of equipment. So there was some challenges and a lot of maneuvering to try to get that seeding depth just right on these fields, but it was very interesting to see a direct comparison between the two. A couple weeks later, you can see here what the double disc left behind compared to that inverted T. So the double disc definitely is more of your classic definition of no-till. You're not seeing any soil disruption there. You're seeing a little bit of that soil popping up with that inverted T tine off to the right, but still definitely not a clean run. So in the end, I know the question is which one performed better. We're still analyzing the results. Broad strokes, we actually noticed a bigger difference between the different seeds, the different species that we seeded. And we saw a bigger difference between the irrigated and non-irrigated land, which is not a surprise, but whether or not one was better than the other, we'll be analyzing those results soon. But another site that we looked at was a pretty good lesson for all of us involved. This was a really extreme dryland site down in the East Kootenays with a really fine textured silty soil. And as you can see in the picture on the left, had some real difficulties packing it down and getting it ready to germinate. And it was a big challenge to get anything to establish over the 3 years, just with that fine of texture of soil, with the dryland conditions that we were facing. But in year 3, we were able to see some establishment some germination and establishment get started. Definitely not the success we were hoping for in that site, but a really important lesson of packing, the importance of packing and getting that seed bed just right and firm enough to move forward so that we have the appropriate seed to soil contact. So field moisture, and one of the first questions we had during our field day in 2019 was, what was the field moisture levels when we seeded? I agree, we should have taken those measurements, but also I know a lot of producers may not have the ability to take those measurements themselves either, but we have since then secured a soil moisture probe to make sure that we can just take some more of that data and snapshots of what the field conditions were as we seed these trials. But field moisture is cited as one of the most important factors in getting a successful seeding. Specifically, competition for moisture is the biggest challenge for new seedlings, which I alluded to earlier when we were talking about competition. With dryland production, it's obviously difficult to manage, and too much or too little. We also, following 2020 and 2021, fought with way too much moisture out in our fields and the inability to get out there, particularly around the Prince George area in those heavy clay soils. So moisture really is a strong determining factor. And so again, we don't always have control over the moisture. So just making sure we're ready to assess the conditions and try as best as possible to work within the right moisture windows when we see them pop up and be available. An example of moisture, so that we got this really great aerial shot of one of our research plots. So the establishment year was 2019. It was the driest spring on record, and this ranch had been operating for within that family for over 100 years, and they hadn't seen a spring that dry. And as you can see here, where they had a pivot and where they had irrigation made all the difference. I believe this photo was taken mid-June, so quite a few weeks after our seeding. Luckily, we did actually, they then turned around and had the wettest July on record, and the dry land did germinate and get established later on that year, just a few months later than expected. And there was quite a bit of kill. So there was some that some of the seed that did germinate and did not make it to GIN. So it wasn't a full catch as to what we were hoping for. But the other thing that we really noted while we were seeding this plot, which I think is worth sharing, is that the producers noticed a huge difference in the performance of the seeding equipment under different moisture conditions. So when we first started seeding during the day, everything was pretty dry. It hadn't rained for quite a while. Partway through the day, we started seeing some precipitation, called it for the day, came back the next day. And with the soils being a little bit more moist, they were able to get a much more consistent seeding depth and just a better running of that equipment in general throughout. I believe both pieces of equipment, both the double disc and the tine. So moisture, field moisture can make or break, and a lot of it can just be luck if you don't have irrigation in place. And so the last kind of major component that we'll be talking about for this part of the talk is looking at nutrient availability. So this came up as a huge component to anything with crop management, but a lot of the fields that we worked with, we didn't, the producers didn't want to use fertilizer or weren't able to. It varied one way or the other, but really making sure that when you're establishing new seedlings that you have the appropriate nutrients available is going to be pretty key to whether or not they're going to be able to establish and move forward. So we all know about nitrogen. It assists with plant growth and yield. We need to look at how much nitrogen we have in the field and available to those seedlings to get a good start. Now I do put a star next to nitrogen because depending on the mix of what you're seeding, if you have a legume going in, the rate of your nitrogen is going to need to vary accordingly. So really dependent on the crop you're seeding in. Phosphorus. We are focusing on the major macronutrients today, but thinking about it in a seedling perspective. So phosphorus does play a vital role in root development, and therefore is pretty critical for establishment of a new stand. So if you're taking your soil tests and you're noticing that you're pretty deficient in phosphorus, that is going to really play a role in how well those seedlings establish and get those roots into the ground. Same with potassium, responsible for root development and yield, but also withstand persistence, disease resistance, and winter survival. So taking a look at those potassium numbers. And finally, sulfur, this specifically looking at legume establishment. So sulfur is required for nitrogen fixation by legumes and for protein metabolism. So I know we have a lot of sulfur deficient soils out in the region. So making sure that you're looking at these components and getting those soil tests in before you start your reestablishment is going to be key to your success. Now, nutrient availability, I'll be diving a bit more into this in the second part of the presentation. But then you're thinking about the differences between till and no-till systems. You're going to get a nutrient stratification in no-till systems. Everything is going to be a little bit more concentrated up on the top surface of the soil. And it's going to be a little bit more difficult to see those nutrients get down further down. We're also going to need to start thinking about our carbon to ratios as a consideration and how you're going to balance those out, particularly in a no-till system. So we'll talk about that. And finally, your soil organic matter. So what's happening in that soil organic matter between a tillage and a no-tillage system, specifically thinking about how it breaks down in a no-till system and how that varies. I included this photo here. I'm not sure if it's visible or not, but this was a field that was plowed under quite a while ago, and you can still see that nice dark line coming in from the organic matter that was plowed under a handful of years ago. So hasn't gone anywhere. but perhaps the roots haven't quite got down there to utilize it either. So a couple of different components about nutrient availability and the difference in nutrient management options between the two systems, something we'll dive into a little bit in the next part. So other important considerations, I couldn't not at least acknowledge that these aren't the only 4 components into field rejuvenation. But when we jump in, the other questions that we'll be having is thinking about timing. Are you thinking about seeding in the spring, in the summer, in the fall or winter? We did do some frost seeding trials, so that definitely was something we played around with, trying to capture that moisture. Seed selection, variety selection, pretty big consideration. Your seeding depth, your seeding rate, and of course your post-seeding field management. How much time are you giving those seedlings to establish, to take a break, to get ready to work for you? So not topics that we're able to dive into deeply here today, but definitely worth mentioning. So with that, that's kind of the summary of part 1 and some key concepts. So I thought now might be appropriate to take a break, have any questions or any discussion. So, okay, so part 2, some specific lessons around no-till field rejuvenation. So again, the 4 concepts that I started with really, I think, can apply to tillage or no tillage, as well as both for hay and pastures. And I'll try to do this both hay and pasture fields for part 2 as well. So for part 2, we're really going to kind of dive into perhaps I alluded to it already, that it depends. So thinking about what soil type are you working on, the conditions, the site history, all of that kind of goes into play when you're considering whether or not no-till is an appropriate option for you to select. We'll dive into a bit of that seedbed preparation discussion. So again, thinking about the use of annuals and as a way to help prepare that seedbed for establishment. And again, diving a bit more into that nutrient management. So there's a lot of questions that I have. When we start jumping into these, it really is complex. There really is no two sites. Often even on the same farm, every field is a little bit different, acts a little bit different, has perhaps been treated a little bit differently. So when we're thinking about no tillage, one of the first things that comes up often in our discussions is soil texture. So are you working with a loam, a sandy loam, or are you working with a clay? So I often hear that producers working with really heavy clay fields do struggle with utilizing no-till really effectively in reestablishing their fields. I don't think that necessarily is universal. I think there definitely are opportunities to use no-till in clay fields, but I think it definitely is easier in a loamy field. And one specific thing that comes up is, how does your equipment perform or not in those soils? So a lot of the time, just talking to producers with a lot of experience, they said we really couldn't get this equipment. We really couldn't use no-till in our clay fields, but until they were able to adapt their equipment. So especially around the closing mechanisms on their wheels. So whether they're using a spike closer or a smooth closer, those mechanisms on your no-till seed drill is going to make quite a bit difference of whether or not you're able to close it up and make sure that you're ready to get that good establishment. And you really have to pay, I learned this the hard way, you have to pay really close to the soil moisture if you're working in clay fields. So one of our sites in Prince George, for example, we had rented equipment. We had a 2-day window to get that seeding done, and the fields were probably just a little bit too wet. We caused a little bit of soil smearing in the soil itself. We did see germination, but we didn't really get any establishment in that field. And if we were able to honestly just wait 4 or 5 days, about a week later, the conditions would have been much more appropriate to get that equipment out there, and probably could have gotten a better catch. But just with the pressures of rented seed equipment. And that's just the nature of farming and research, I suppose. But definitely thinking about the texture that you have and matching that with the equipment options. Your soil conditions. So we're rejuvenating a field probably for a reason. There's probably something going on there that we want to address. We hear a lot about compaction issues throughout the central northern interior. So are you dealing with a really compact soil? What does the structure look like? Do you have really good aggregation going on? What is your rooting depth? All of those pieces can kind of help assess if you have perhaps a soil with a bit stronger of a structure, you're seeing that better aggregate, you're getting some good rooting depth. It's possible that that no-till is going to be well suited to help you continue to work in those fields. The field conditions, is it sod bound? Is it pretty thick there, or are you seeing some bare soil? You're going to see the equipment shift. In the no-till equipment, we saw it shift completely, depending if we were in a real sod-bound part of the pasture or a piece of the pasture that was rejuvenated more recently and hadn't quite developed that sod. And how much residues are present? How can that equipment push through those residues to get that seeding depth that you're looking for and that uniformity? And again, what's the site history? So what's currently growing there? Are there weeds or an invasive species issue? Are you using it as a winter feeding site? That might impact the residues. So all of these things can really factor into the approach that you take, the specific no-till equipment that you're utilizing, and helping determine the success. So I've tried to give a smattering of the different types of fields along the bottom of the slide here, the different conditions we started working with throughout the program. And as a very wise person who I believe is on the webinar tonight said, it's really easy to no-till once you've already tilled it up and smoothed it out or something along those lines. So a couple of examples of what I really see as one of the big successes for this trial was by kind of diving into these concepts, by asking these questions and really pulling apart what are the different components that are going to work into reestablishing a field. One of our farm partners was able to take a look at the field, was able to take a look at other dryland fields that weren't part of our research plots. And they were able to identify, you know what, I think under these conditions, it's worth throwing a little seed in the seeder and going out there and seeing what we got. So they were able to look at, they were able to find some patches of their pasture that weren't sod bound, that they were seeing some openings, a little bit less competition. They were able to see that the moisture was just right. This was a few years after our first year of setting up the trial. The moisture conditions were right, and they just had a little bit of extra seed left over from the other seeding they had done. So they brought the equipment over and they seeded this patch just to see what it would do. And it might be difficult to see in this photo, but the kind of the lighter colored strips here of clover coming in successfully not only germinated, but established. We didn't grab a photo of it here, but they were pretty excited to see that it started. So we ended up putting a grazing exclosure around a section of the field, and they were able to actually see the growth and the establishment and where it worked. So again, it wasn't a full field establishment. It were just small chunks of the field that were out there, but they were able to kind of get the best bang out of their buck. And I've been corrected. No-till is a lot easier after you till. Thank you, George. Yes. And part of that, and part of what I didn't have a picture of with the producer I was talking to this about near Stoner, just south of Prince George, but they had just had a beautiful reestablishment of one of their hay fields. And as we were taking a Sunday walk and talking about it, just curious about why they had chosen to do a full rejuvenation where they disked it, they harrowed it, and just got this really great tame forage field established. And why they decided to do that, they're like, well, it had been about 30 years since the last time we really turned everything over. We had done no-till twice, and you know, the cattle were in there when it was a little wet. You were starting to get a little pugging. It was getting pretty uneven. Like you couldn't get the seeding equipment to work quite right. It was time to do a full rejuvenation, to disc it in, to harrow it in. And it was a really great establishment, beautiful crop that came up. And they're like, and now that the field's in this condition, I can probably go ahead and no-till it for the next couple of times when it is time. So if you're starting with a relatively flat, relatively like ready to go, that field, kind of what I've shown here on the left, that might be ready. That might be a good candidate for no-till. And I'm picking up on on the right-hand side where if this wasn't obviously a full field, but if you're seeing pugging, if you're seeing a really uneven ground, the chances of you utilizing a no-till approach and getting a really even, strong establishment will be a lot more difficult, if not impossible. So this is really just to say that we really need to think about the specific conditions of the fields that you are in and determining what's going to work best moving forward. So seedbed preparation. So a question that we had earlier. When it comes to tillage or no tillage, we're really needing to think about how are we preparing that field and that seedbed to be ready to take on those new seedlings, to ready to reestablish a really thriving crop, and what that condition is the soil in that field in, and is it ready to support that growth. So even if a field has been selected for rejuvenation, there's some existing challenge that's there, whether it's productivity, stand density, weeds, or other invasive species. And so we need to think about what techniques we're going to use to help make sure that that field and that soil is ready to establish a new perennial crop. And often I've seen this pretty frequently, obviously, done with annual crops. So if you're moving from a perennial field and wanting to reestablish it into another perennial stand, taking that field and putting it into annual forage production is a pretty common strategy, and particularly beneficial in a no-till system, as it's going to help break up that sod. It's going to help give you some time to get that seedbed ready to go. So this is also particularly true if you're worried about autotoxicity in your alfalfa or allelopathy. So if you have a field with some existing alfalfa crops, plants, even if they're few and far between, alfalfa, the roots actually exude a chemical that doesn't allow new alfalfa plants or hinders new alfalfa plants to establish. So if you give it a few years of different crops being grown in that area, then when you go to reseed alfalfa, there'll be less of a chance that those chemicals still being in the soil, and you'll get a stronger establishment. By doing this, by utilizing these annuals for 1, 2, or 3 years, it's giving you the opportunity to create some biodiversity in your stand, to use the different crops. You're going to perhaps get to choose some crops with different root systems, with different residues being imported in, all of those pieces. And so when we're thinking about these crops, these cover crops, which we talked a lot about last week, which is great, often the mixes that I'm really familiar with, that I see a lot of producers looking at, are an oats barley peas or an oats triticale peas. Last week we saw the benefits of having a legume mixed in there and being able to have these different rooting systems into those fields, and giving the time for your soil to either break up the sod, maybe help get rid of some of those weeds, some of those pressures. You can also use, obviously, cocktail cover crops, which we talked a lot about last week. Particularly, those will give you even more diversity in the crops that you are using. And what perhaps is also pretty an opportunity, I would say, by utilizing annual forages as a way to break up the perennial cycles and to prepare your seedbed, is it might also provide an opportunity to integrate livestock into the field. So that regenerative agriculture principle of, we heard Renee last last week talk about, well, I don't want to bring my cattle back into my hay fields. I don't want to regraze that growth. I want to keep those hay fields in good conditions. Well, if you're rejuvenating one of your fields and it is an annual production, you might be able to grow a crop specifically for extending your grazing season, or perhaps you could grow an annual crop and then have a relay crop to get some extra growth into that field, or perhaps you could do some bale grazing on it. And all of this, I'm putting it under seedbed preparation because it also might be a way to really think about your nutrient management if you're able to bring livestock back onto that field. So for an example of kind of thinking about seedbed preparation and the utility of using these annuals, we had one producer who did look exclusively at cover crops for all 3 years of the trial. And it was really, really exciting to see how it progressed and how it worked. So did decide, I think we thought it was going to be 2 years and back into a perennial, but ended up doing a full 3 years of growing cover crops. Did start small, which is highly recommended. So took just a quarter of the field that they were working with. By the end of the trial, they were utilizing half of this field under cover crops, and they followed the practice of terminating the field in the spring. I believe they took one cut off of it in the summer, usually as a silage crop, I believe, and then they would regraze the growth, graze the regrowth in the fall. I will note that these fields were under irrigation, but they were also quite a sandy loam soil. It was a mixture of 3 different associations that ranged from 50 to 90% sand. So a pretty sandy site. So the irrigation was much needed. And the goal really of utilizing these cover crops was, one, to increase the organic matter, which we heard in the first few presentations, the importance of all the organic matter, but also to extend their grazing options into the fall. So the photos I've shared here are from the first year, so 2019. You can see kind of in a clockwise fashion, I guess. Got a really good kill, got a good termination of the field. You can see some of it getting started. And then definitely grew, definitely took off, got a really good establishment there. And a few photos of the size of the brassicas in that first year during, I believe this was for the first harvest as well. So, and I should also note, in the first year they trialed, I believe, 5 different mixes of cover crops, and then based on the performance, we're able to kind of go through and which ones were working for them for different reasons, and kind of hone in which exact cover crop mixture worked best for them. So love these photos. And then going into year 3, this is the regrowth from last fall. I believe it would have been September that we were down there taking the photos. So year 3, we're seeing some very large turnips growing out there, very like regrowth of this after it's been cut, really large leaves, and perhaps maybe not immediately noticeable. We got a beautiful little dog there for size reference in that regrowth. So really just exciting to see that much cover crops. I believe it's slotted to do go back into perennial this upcoming spring. So I'll be excited to kind of follow that along and see how it works. They also were able to start winter grazing on a portion of this field as well, something that they hadn't done in the past. So again, just taking an idea, something they wanted to try, starting small and slowly building up and making it work for them. So pretty exciting there. And maybe after next year, we'll be able to get some establishment numbers to go along with these 3 years of seeing the cover crops thrive. So nutrient management, I promised I'd dive a little bit more into this. Obviously, nutrient management, there's a lot that goes into nutrient management and the different components. And so, as we already mentioned above, the main goal is that we are meeting the nutrient demands of the crop. So we want to make all the decisions looking at what is already in our bank, what nutrients do we already have in the soil, and what is going to be needed to make sure that crop can reach its full potential. Now with no-till production systems, one piece that we really need to think about, and I probably should have specified more on the slide, is that if you're in a no-till system and if you do and you herbicide out, you spray it out the sod, you've just created a whole bunch of more residue sitting at the surface of your soils, a whole bunch of food for your microbes. So when you go into no-till, you're likely going to see an increase of microbial activity, but just straight up at the top of the surface. And it's going to work to slowly decompose the sod and the residues sitting up there. So whenever you're looking at your nutrient management, one of these nuanced discussions that we've started to have is looking at the carbon to nitrogen ratios of the residues going into your soil. How is that impacting the microbes? And therefore, how should that inform your nitrogen management or your nutrient management? So with residues with a CN ratio of less than 20, you're going to expect pretty quick decomposition. And a lot of the producers I work with, they have an idea of where their soils are at, of how long it takes for them to break down the residues that are on the surface. And if you're seeing it move pretty quickly, that's a good sign you got that active microbial growth. Residues with a CN ratio of more than 30 are going to have a much slower decomposition, and you might actually require additional nitrogen to make sure that you get you're meeting your crop demand. So if you have residues going into your soils, straw, we already talked about wood and some other resources. Microbes are actually going to be pulling nitrogen out of the soil to help decompose those residues with a high CN ratio. So if that's the situation, it doesn't necessarily mean it's a bad thing, but you have to make sure that you're going to be supplementing that nitrogen and making sure that you're still going to be able to get that good crop growth and good establishment. And the process of decomposing the organic matter is going to impact both the soil carbon and the nitrogen availability. So what we kind of touched on, and I'll dive even more on the carbon part in part 3 of our talk today. When we're thinking about no tillage, it comes in nutrient management. We're thinking about mobility, the nutrient mobility, and how do you match those crop demands when really you're looking at putting nutrients really just on the surface of the soil, unless you have some capacity to band it in. If you're using minimal till, if there's an ability to band in. This is particularly important for any nutrients that are immobile, such as phosphorus. It can really be difficult if your soil tests are coming back that you're deficient in these nutrients. In a no-till system, it might be difficult to get those nutrients placed exactly where they need to be into the soil. So it's just something that you need to consider. And with a no-till system, you're not going to be able to actively incorporate other inputs that you have, like you would if you were using some level of tillage. So manure, some compost, really, you're building it all on the surface. It's not a bad thing, just something to keep in mind. Your options do change a little bit, and we need to adjust for that. Okay, so that was wrapping up part 2. Any questions or comments? Yeah, for now we'll jump forward and talk a little bit more about soil carbon and tillage. So, all right, soil carbon and tillage. So again, so to till or not to till, and why should we care? We hear a lot about the benefits of no tillage or minimal tillage or conservation tillage. These are a few examples of some erosion that can be associated with tillage. Field on the left obviously is the opportunity for dust and wind to take away all your topsoil. And the picture on the right is particularly of interest for anybody working on sloped fields. So having that slope and tilling it up is a pretty quick way for your soil to move around and follow gravity and hopefully not cross property lines and giving your neighbor all the good stuff. But tillage, we're really about trying to look at soil health. As I mentioned earlier, we'll dive into a little bit more information specifically about thinking about soil structure and what tillage does to your soil structure. I've mentioned specifically some concerns around soil erosion, and all of that too is how does tillage actually lose soil carbon. And on a practical sense as well, if we can find ways to successfully utilize no-till systems, it does reduce the number of passes of iron across the field, likely saving you time, perhaps money, and reducing greenhouse gas emissions, which we can all benefit from. So kind of taking a step back, thinking about carbon itself and the carbon cycle. So carbon is constantly entering the soil through decomposing plant materials, root exudates. So actually a lot of carbon coming right from the roots of the plants themselves, as well as the soil organisms that feed on the root exudates. So the soil organisms themselves, as they live their life cycle and also die, the residues of that biomass also accumulates as carbon into the soil. So nice graphic here that I've borrowed. So looking at that plants use carbon dioxide from the air and the water from the soil to build those carbohydrates. The plants exude carbohydrates through their roots to feed the soil organisms, and then the soil organisms will then break down some of the organic matter and release carbon dioxide through respiration. So soil organisms breathe CO2 just like we do. So that's kind of thinking, like broad strokes, thinking about the carbon cycle. A couple of terms. So soil organic matter, which often I will shorten to SOM, is composed of many different elements. So carbon, hydrogen, oxygen, nitrogen. And so soil organic carbon is just a portion of the organic matter. So some little nuances there in the terminology. So as I said, soil is coming, we hear a lot about the plant residues. So all the residues, that's where all the soil carbon comes from. There's also opportunities to add more carbon to your soils through inputs. So compost, mulch, pulp mill sludge. Again, not going to touch on these because Josh did in an earlier webinar, but thinking about additional inputs into that might add carbon into your soil. And so you can see all the benefits from soil organic matter that we've also discussed already. And plant roots. And this is what gets me really excited. I did a term paper back in my university days that really got me interested in really sorting out how plant roots contribute to stabilized soil carbon. So we do have growing evidence that roots actually potentially contribute more relatively stable soil carbon to that stable soil carbon pool compared to the shoot-derived carbon coming from the plant materials. So that it's a really big opportunity, particularly in our perennial grassland systems, that we have these huge opportunities for substantial root growth and that root to shoot ratio of our grass systems. And that's why I think we're seeing all this new attention to the potential of carbon sequestration in our grasslands. A lot of it is looking at these more stable soil carbon pools compared to the more labile or active soil pools that are really moving around quite a bit more back between the atmosphere and back into the soil, etc. So like any good student, I went back to a favorite textbook and borrowed one of their tables that are looking at the factors that affect the balance between the gains and losses of organic matter in soil. So starting first, it's a pretty big, complicated, lots going on in the table, but factors that are promoting gains, that's when we start talking about green manures or cover crops that Jillian touched base on yesterday. What we're talking about today, conservation tillage, the return of plant residues, low temperatures and shading, controlled, and I've added managed grazing, high soil moisture, surface mulches, application of compost and manures, appropriate nitrogen application levels, high plant productivity, and high plant root to shoot ratios. So these are the items and the conditions where we could expect to promote gains in our organic matter in the soils. On the other side of things that might promote losses or reductions of our organic matter, soil erosion, what we've already talked on, intensive tillage, whole plant removals, high temperatures and exposures to the sun, overgrazing, low soil moisture, fire, which we've seen quite a bit throughout the province, application of only inorganic materials, excessive mineral nitrogen, low plant productivity, and low plant root to shoot ratios. So definitely don't have time to dive into all of these different factors. So keying in on some of the ones, obviously, let's jump right into the conversation of tillage and what tillage looks like to our organic matter. So tillage really does impact our soil health. So the one thing that it does is it really does break apart the physical structures of your soil. So what we call aggregates, both the big macro aggregates and the micro aggregates. And so by tilling up the soil, disking and or plowing, you break up all the structure, everything that's bonding the soil particles together, and that will increase your chance of erosion. So that's where those risks come into play with tillage. Now, at the same time, this is also going to disrupt your biology. Here, I've only mentioned microbes who live in the aggregates. So those aggregates provide nice little stable structure homes for the microbes. So when you break all of those apart, you're also going to be disrupting the microbes that exist in any fungal dominated systems. If you're thinking about mycorrhizae that have developed, obviously tillage is going to break apart those pieces of biology as well. And it's actually going to lead to the increased decomposition of organic matter. So yes. So one of the more limiting factors of decomposition in our organic matter is oxygen aeration. So if we start talking about how this is happening, there we go. It really is all about the fact that tillage is adding more oxygen into the soils. And if this is the limiting factor, you're actually, by aerating it, the microbes have all the oxygen they need to break down the soil organic matter faster and therefore release that CO2. And that's where that carbon loss comes from in relation to tillage. And one of the major ecosystem functions and services that we get from soil organic matter really is related to it being a source of nutrients and subsequently those nutrients being used for plant growth and crop growth. So when nutrients are being released through this decomposition faster, and these activities are not in sync with the timing of the plant demand, that's when you're going to start seeing those losses. So no matter what, you're definitely going to see the losses of that carbon. But with this increase in decomposition and the timing that might be off, you might also be losing some of those nutrients that you've been building up as well. So the relative decomposition rate of soil organic matter is a very important metric that we need to be thinking about when we're talking about this discussion around tillage. So again, if I included these photos here, if you're not really sure quite what like some good strong aggregates look like, this is maybe this is a really heavy clay soil that formed these aggregates, I believe in the Bulkley Valley. So it does exist, it is possible. And again, if you are looking at tillage, you're moving all of that organic matter down deeper into that layer where it may or may not be all that accessible to the plants themselves. One kind of nuance that I think often gets missed in a lot of the mass media discussions around tillage is really around tillage intensity. And particularly even around a lot of the scientific studies that I've read. I have to admit, I'm not able to keep up as often as I would like on all the new published work, but a lot of the time when we're seeing all these studies coming out talking about how tillage has lost all of this organic matter. They're often talking about very high intensity tillage systems, which may or may not be equivalent to what we're looking at in a forage production system, at least not the systems that I've seen. So when we're thinking about the damage that tillage does do, I think we need to think about it in the long kind of framework. And what level of tillage are you doing? So are you doing a full plowed under? Like, are you doing a full plowed, disc 3 times, harrowed, and then seeded? Are you doing this once a season, 3 times a season, 7 times a season? There are definitely annual cropping systems that require tillage 7 times a year. And so obviously that's a much higher intensity than we're likely going to be seeing in a forage rejuvenation system. There are also minimal or conservational tillage options. We heard a really great description of a vertical tillage system being utilized, where it's providing that aeration, helping with the compaction issues that they're having in those fields, but it's not a full turnover. It's not even a disking. And seeing some really good success with that in combination with some light harrowing to get that smoothed out field. So yeah, and how frequent are you doing this? For better or for worse, most of our producers aren't rejuvenating their fields every 3 to 4 years even. A lot of the time, I'm hearing a lot of numbers around 10 years, 12 years, 15 years, 20 years. So it's a nuance to the conversation that we want to have. So not to say that all tillage is bad, but just that we what level of intensity are we talking about, and how often is it being used? And in the field, in the picture that we have here, it actually wasn't tilled at all, just harrowed to try to make sure we didn't damage the cedar. But still, obviously, seeing some dust, some erosion, that was a consequence of using that. So definitely a nuance there. So going back to our, and there's just a few more points that I wanted to pull from this table. And it really is coming back to nitrogen, coming back to nutrient management. So you'll see that the table doesn't say that all nitrogen is bad. We're looking at appropriate nitrogen levels, and we are minimizing excessive mineral nitrogen. So it really is about finding a balance. This topic in particular, I've been trying to dive into a lot more over this winter. I've been trying to learn a lot more about myself. And when we think about the nutrients and soil organic matter, the inputs of organic matter may be plant dominated, but it's actually gradually becomes dominated by molecules derived from the microbes themselves. So when we're thinking about the whole shift in nutrient dynamics and the biology of the soil, we have to think about the role that the microbes are playing in that cycle. So the microbes require nitrogen to function, and then they're going to break down the soil organic matter and cycle those nutrients back around for plant growth. So if those microbes are actively pulling in that nitrogen, if it's pulling in all the available nitrogen, it is going to limit the plant growth that you have available, unless you're able to compensate it, unless you're able to find a way to make that balance. So the more that I've looked into it, it's more about a question of balancing nitrogen and carbon in the soil, among many other things, obviously. But that balance is going to be impacted by the quantity and quality of the inputs being put into the soil. So there's a lot of great resources. We've shared a bunch through our resource roundup. More will be coming forward on this topic, but really thinking of it, we need to look at the whole slew of tools that we have access to, and finding a way to meet that balance so that we're able to keep the microbes happy. We don't want to supply all the nitrogen and make them lazy or anything like that, but finding that balance where we can really get a good level of decomp with the soil organic matter, and everything's kind of working together. And a piece for me that always has kind of rung true in these discussions of soil organic matter and to till or not to till is that when you're thinking about soil organic matter and getting more carbon into the soil, at the end of the day, high plant productivity with really good rooting systems with that really high plant root to shoot ratio is going to put in way more carbon into your soil than low productivity plants. So if you are if there are certain techniques that aren't giving you good establishment, then if you try to utilize a no-till production system and you're getting low plant productivity, you're not getting strong establishment, you're not getting any more carbon being put into the ground. So it might be worthwhile, depending on your site conditions and all of those components, that figuring out maybe some level of minimal tillage, conservation tillage, or potentially, depending, like if it's pretty rough out there, a full disking and tillage might be appropriate to get that high plant productivity and then actually get more carbon putting into the ground. So when we're thinking about soil, increasing our soil carbon, I really think the question should be about what is the best method to get healthy, vigorous plants established, and not go into our corners of that there's only one approach or one solution. I think we really just need to concentrate on figuring out what the best tools are for the conditions that you're in. And that perhaps, therefore, a more realistic goal or approach when we're thinking about a perennial forage production system is that we want to rejuvenate fields and balance that carbon loss with the carbon gained with the new crop growth that we have. We really want to focus on establishing healthy plants and then managing them to keep them productive for as long as possible, and only use strategic tillage. There might be a time where it's needed. And as I started off saying, I'm obviously very committed to applied research, the reality of our decision making. Yes, absolutely. What are the conditions of your field? What is going to be realistic? And it might very well be informed by what equipment is in your barn. Maybe what equipment's in your neighbor's barn. But a lot of the time, unless you're in a position where you're looking at investing into some new equipment, just learning to work with the assets that you have, and again, just minimizing the carbon loss while trying to realize the opportunities for carbon gain. Some key messages and summary, and then we'll be able to open up for a full discussion. So a lot of this last part 4 is going to be reiterating some of the points that we've made already in our discussion. So the first thing is really, it is important to take an assessment of where you are, take stock of the situation, and kind of assess what needs to happen. So what is the plant composition of the fields in question? What's the stand density? Is there a changing species composition in that field? Is that what triggering the need to rejuvenate? It could be for the good or for the bad. Is the goal that you want increased yield, or is the goal that you want increased quality? Really kind of diving into the motivations behind rejuvenating that field is a really good kind of first stepping stone into this. And a lot of this really was around, like, do you need a full root rejuvenation? Is that the stage that we're at? One of the resources that we shared prior to this webinar was when Dr. Bart Lardner joined us last year, who did an excellent job of really pulling apart, are there in-between steps that we can be taking to prolong the life of the field? Can we utilize some nutrient management to help shift the species composition or to bring some life back into that? Might be more feasible in some years other than others, depending on the costs associated with that. But really kind of taking in that step of what is needed here, and are we ready for a full rejuvenation? And what is your time frame? That, like, is this something that we need to be rejuvenated right now, where you have a forage deficit window, and you really need to make sure that you're filling that in the short term? Or is it something that you have a little bit more time to work with, can try different practices and kind of evaluate whether or not they work? And equipment availability, obviously, is kind of an assessment of the approach you're going to take, whether it's power harrows or vertical tillage, or the different no-till options that we've looked at tonight. Availability of seed is a huge question, of not just the species that you're looking for, but also of the varieties and the cultivars that you're looking for. Depending on where you're located, can definitely be a limitation. And that's actually what we jumped up as the next big thing. Key messages is species selection. It really is pretty critical, and it's a whole extra topic, making sure you're selecting the right species for the purpose. And that really does differ, if particularly when you're thinking about between pastures and tame fields. Which species are really grazing tolerant? Which species are a better pasture legume rather than a cultivated and in a hay production system? So there's a lot of components to making sure you're selecting the right species, as well as making sure that they're regionally suitable. Now, we do have some resources that are already available that might help answer some of these questions. We had an excellent webinar, don't know if it was 2020 or 2021, looking specifically at species for dryland production for Highway 16 in the central interior. So that link was part of the resource roundup, and happy to make sure that that's available for everybody to kind of get a sense of the different characteristics of the different species that exist. There is a Forage UPIC tool that was that you can find through the Beef Cattle Research Council. Definitely something to look at. It has not yet been trialed in a real meaningful way in BC, but it was designed as a way to incorporate the climate and the soil types of BC. And I would say that the resources are coming. So this webinar series is designed specifically, we're open to everybody, but the content is specifically designed for producers within the central northern interior. And there is a project from the Climate and Agriculture Initiative for the Bulkley, Chaco, and Fraser Fort George regions that is currently underway. We have a fantastic contractor, Nadia Mori, who is working on developing some specific resources and including some workshops around identifying regionally adapted forage seed for and helping us actually beta test that Forage UPIC tool of how reliable is it to kind of come up with some decent recommendations of the seed that you should be looking at. The project is being administered by the Eaglet Lake Farmers Institute, and the Forage Council is an active partner, and they are currently doing a bunch of producer surveys and collecting a bunch of information about the current use of species. So if you're interested in this project, please make sure to reach out. I've included the BC Forage Council email there, bcfc@bcforagecouncil.com. It really is a whole component to field rejuvenation that I couldn't do justice or even near justice here today, but didn't want to ignore it either. So hopefully coming away from the webinar, I've been able to give an approach to kind of think your way through field rejuvenation and what may work, what may not work. I do suggest some key messages. No matter what you decide to do, write out a plan. Putting pen to paper can really help sort out, maybe hopefully identify where there might be some resource gaps or things along the way. And when you're writing out your plan, identify how are you going to manage that competition? Is it going to be mechanical? Is it going to be a herbicide? Are you going to use some grazing? Is it going to be a combination of some suppression techniques? What is out there in your field? What is it going to be a heavy amount of suppression that's required? Or is there some less competitive species that you're working with? How are you going to achieve that good seed to soil contact? A pretty big question, particularly in no-till. If you're working with a sod layer, how are you going to get it through? working through what are the moisture conditions of that field. Is it generally extremely wet? Is it something you can't get onto in the spring? Is a fall seeding more appropriate? Just kind of where are your moisture windows, and trying to be as flexible as possible in the dryland production systems that we have of identifying and capturing those moisture windows when we can. And take a soil test and find out are there any nutrient deficiencies that need to be addressed, and how are you going to address those to make sure that those seedlings really do have the best shot at working. Now, we all have a plan, and in my experience, usually things in ranching don't go to plan, and usually things in research don't go to plan. So it's a great combination to go with both. But after you've written out your plan, make sure to record what actually happened. How did things have to be adjusted or changed? As I like to say, I've definitely learned how to be far more flexible on caribou time. It's a skill, it's a necessity to be successful in this business, but recording what actually what happened, the date that you seeded, what the conditions were, and going out and measuring what your seeding rate was, what your depth was, and then going back and measuring some of your germination and perhaps establishment. It really makes a difference. It's really challenging. I love talking to farmers and finding out what they've been working with, and they'll say, oh, I've tried this one thing, but it was a complete failure. I'm never going to try it again. And and there's all these questions of like, well, what were the conditions like that year? What did you do this? There's like, and if you don't write it down, you might not be able to work backwards to find out, is this really an unsuitable practice? Is this really an unsuitable species to be seeding? Or was there something else that led to the failure of establishment? So recording information of what you actually did is really important. And I love that quote. Thank you, George. Everyone has a plan until they get punched in the face. So Mike Tyson, that sounds about right. And so you're recording what happened, and then really assessing with measurements and reevaluating what worked. So it's really key. Driving by a field and is not a full assessment. I put back the photo from the earlier plot where we can see these lines. Like the first photo, I was like, oh, that's great. Like we got some germination. But if they hadn't put out that grazing exposure, if they hadn't allowed to see in that pasture what the potential, did it actually establish, did it stick around, how productive was it, they wouldn't really have been able to know whether or not it was true. They might not have been able to really assess whether it was successful or not. And in this photo below, it was just, for me, it was astonishing because we had such a difficult time with this field of getting it established. And after 2 years, it was in the East Kootenays, and they're like, oh, nothing worked, nothing established. There was nothing out there. I don't know what to do. And then when I got down there, you can see some pretty clear rows. And that's all bird's foot trefoil. It wasn't perhaps the success they were looking for. And it looked like nothing from afar, but going out there and actually measuring what's happened, it can be very telling. And in this case, you can see, I don't know if you can see the cursor on the screen or not, but you can kind of see there's these patches of definitely the sod and the old competition remained, and then in between these rows of bird's foot trefoil. And it actually ended up being an issue with the water quality mixing with the herbicide that nullified the herbicide. So they weren't able to get a full kill like they were hoping to. They ended up sorting out the solution later on. But yeah, it just really brings back home to go out there and really do a full assessment. And I'm happy to say that the few lessons that we've learned, both about seeding rate and seeding depth and figuring out that water quality for the herbicide, and this was a small patch on one of their fields, but it led to them being able to approach other field rejuvenations to a high degree of success in the years following. So taking a small chunk of a small area, trying something, learning from it, and then applying those learnings to larger areas is still a win in my books. And so as the last kind of key message is, the answer often is it depends. And knowing what works best for you and your operation is going to be the critical component to your success. And I don't do it facetiously. I really do. The reason I love forage and working with the forage and cattle sector is that it's so complex. It's so integrated. There's so many different components. There's a lot of questions you have to ask before you can kind of get to sort out what might be the best tool for your situation. And one of the tools that the Forage Council has developed that I think it can be very, very beneficial is the on-farm demonstration research. So we do have a full guide on how to set up a research plot. These were the principles that were used to set up all 14 of the research plots that we have. And it really does walk you from start to finish of how to set up a site. And when you're starting something new, start with a small area. Kind of assess how much you're able to risk if it doesn't work out, and go from there. Just definitely starting small and simple and not making it more complicated than necessary is really important. And actually, the Kootenay and Boundary Farm Advisors, in collaboration with Dr. Catherine Tarasoff, has even now developed these grab-and-go templates for on-farm research that are quite extraordinary. I believe we've already shared a few through our resource roundup, but more will definitely be coming for anybody who are interested in those as well. And at the end of the day, take measurements, take photos, and write it down. I can guarantee you will not remember what happened. And the more photos, the more notes, all of those pieces really help sitting at the table over winter and kind of a reassessing the situation and making plans for the years ahead. So for all the programs that we've developed, substantial contributions, obviously, from our funders wouldn't be here without them. So looking at funding from the Climate and Agriculture Initiative, the Canadian Forage and Grassland Association provided contributions as well. The BC Forage Council put in cash contributions, and then additional funding from Investment Agriculture Foundation, which is provided in part by the governments of Canada and British Columbia under the Canadian Agricultural Partnership, which is a federal-provincial-territorial initiative. Got to tease all of our farm partners and our ag support. None of this work would have been possible without them. I can't tell you how gracious all of your time has been. I'm definitely still feel that I'm new and green in working in this field, and the immense knowledge of our farm partners and all the additional ag support that we've received throughout this program has just been really illuminating, and I really do appreciate it. I do have to say that we have some elusive folk that we couldn't find a photo for, so also just a quick shout out to Jerry Karchuk, Dale McNamara, Blake Goddard, Michelle Miller, and Mike Witt. Thank you guys all and everyone captured in these photos here that really have made working on this program a sincere pleasure. A few of the references that I've made throughout the presentation. Yeah, and with that, yeah, open to spend the last 10 minutes here with more questions, more discussion amongst the group here.